This section is on quadratic functions and the properties of quadratic functions. I'm going to write quadratic function properties. So you need to have your notes right in front of you. And I don't think you actually need your graphing calculator. I'll tell you if you do, and you can pause it and go get it if you need it. So let's look at the top. It says the simplest quadratic function is y equals x squared. And we've been using that a lot. You learned that one in your library of functions. It looks like this. We've used it as a parent function when we did transformations. This is the point. It is the vertex, happens to be a local min. And if I created an XY table to show points on that graph, I'm going to do it like this, equals x squared. If I pick 0, then f of x would be 0 squared, which is 0. Let me create the third column. I kind of like doing it like this, which gives us the point 0, 0. If I pick x is 1, I get 1 squared, which is 1, so that gives me the point 1, 1. If I pick negative 1, I get negative 1 squared. Notice it's in parentheses, which gives me positive 1, so I have this point. If I put 2, I get, oops, I didn't need parentheses there. I get 4, which gives me this point, and let's do one more. If I pick negative 2, I still end up with 4, and I have the point negative 2, 4, and we could keep going. And you can find all those points on the graph. Okay, it's a real easy one. Well, what we're going to look at today is, instead of using just this parent function, we're going to look at, in general, all quadratic functions. And all quadratic functions have two forms. In other words, they can look one of two ways. So form number one is this. F of x equals some number times x minus h squared plus k. And that's different. You're not used to that form. Well, in that form, which is a very, very handy form, we can read the vertex right off of it. And the vertex is the point hk. So hk is that vertex. And we'll work with that form in a minute. The form that you're used to from prior classes when we were learning to graph quadratics is this. F of x equals ax squared plus bx plus c. In that form, the vertex is a little harder to see. It takes some calculation. In form 1, I can read the vertex right off of the equation. But when a quadratic function is in form 2, that vertex is the point negative b over 2a, and then f of negative b over 2a. And if you're like, what? Don't worry, we're going to work with this in just a minute. Let's look at some other information. If the a, meaning this a, if that a is greater than 0, then the parabola, which is the graph of a quadratic function, opens up. That's like the one I did up here. It opens up with the arrows pointing up, okay? So if the a is less than 0, if it's less than 0, that should give you the idea that the parabola opens down, which would look like this. Okay, let me draw this one. This up one would look like this. Now notice the a can't be 0, because if it's 0, it's no longer a parabola, because there's no longer a squared term. So it only can be greater than 0 or less than 0. So to find the x-intercepts of that parabola, you let y equals 0 and solve for x. To find the y-intercept, same as with the line, you let x equal 0 and solve for y. We have in a parabola what's called an axis of symmetry. Our parent function up here, the parent, is symmetric to the y-axis. It's an even function. But it doesn't have to be there. If it sat like this, it's still symmetric, but it's symmetric about another line, a different line, and we call that line the axis of symmetry. And that line is the line x equals negative b over 2a, just like we found for the vertex. So that line is going to go through that vertex point. I think this is kind of self-evident. The vertex is either going to be a max point. If it's a max point, that's when the parabola is opening down. Or it's going to be a min point. If it's a min point, that's when our parabola is opening up. And I think that's kind of self-evident, okay? So just keep all that in mind, and let's actually look at an example. So let's look at example 1. We have the function f of x is equal to negative 3x squared plus 6x plus 1. First off, let's go figure out what form is that in. Does it look like form 2 or form 1? It definitely looks like form 2. It's already been squared and multiplied out, and so we know that that's form 2. Okay, so let's answer some questions about it. Does it open up or down? Well, how do we know? We look at the coefficient in front of the squared term. We look at our a. The a here is negative 3, and since the a is negative 3, it opens down because it's less than 0. All right, let's look at B. It says find the vertex. Okay, the vertex is the point negative b over 2a and f of negative b over 2a. That's the point. So let's find negative b over 2a first. Well, let's finish our a, b, and c. Our a is negative 3. Our b is a positive 6. Our c is a 1. I can just read them right from the equation. So negative b would be negative 6 over 2 times a, negative 3, or negative 6 over negative 6, which is just 1. So the first part of our vertex, the x part, is 1. And now we need to know what is f of 1. That's what this part means. F of 1 means take a 1 and plug it back in for x. So it's negative 3, take out the x, put in the 1, squared plus 6, take out the x, put in the 1, plus 1, or negative 3 plus 6 plus 1, which is equal to 4. So that's the second part, and there we have found our vertex. So unlike form 1, we couldn't just read the vertex off of the equation. We had to do some calculation. Not hard calculation, but calculation. So now let's go to C. It says, does it have a max or a min point? Well, it opens down, so just sketch it. Which one does it have? It has a max point. And where is that max point? The max point is at the point 1, 4, at the vertex. You actually had already answered that in a different way. Now it says to find all intercepts. Okay, so let's go to D, and we're going to first find our x-intercept by letting y equal 0. This is the harder of the two, okay, of the two intercepts. So we have to let y equals 0. In that function, f of x equals negative 3x squared plus 6x plus 1. Okay? So if y is 0, that means f of x is 0. They're the same thing. So we have to say negative 3x squared plus 6x plus 1 equals 0. All right, how do you solve that? Well, first, since it's already equal to 0, I'm going to see if I can factor it. Are there factors of negative 3, long process, that add up to positive 6? No, there's not. So I'm going to use the quadratic equation. So I'm going to say A is negative 3, we already did this, B is 6, and C is 1. And to find x, it is the opposite of B plus or minus B squared minus 4 times A times C, you still have to know that, all over 2 times A, or x is equal to negative 6 plus or minus the square root of 36 plus 12 over negative 6. You cannot cross cancel yet. So x equals negative 6 plus or minus square root of 48 over negative 6. You still can't cross cancel yet. We could simplify that and show it as a radical, or if you were wanting to graph it, you could actually put this into your graphing calculator and see what that is as a decimal. Okay, so it splits here, and we have negative 6 plus square root of 48 all over negative 6. Put that in the graphing calculator. Oops, I said you didn't need it. You do. Or negative 6 minus square root of 48 all over negative 6. Well, when you do that, this one comes out to be negative 0.155, and this one comes out to be 2.155. So what are the intercepts? The x-intercepts, we have two of them. Remember, y was 0, so we have the point negative 0.155, 0, and the point 2.155, comma 0. Those are my x-intercepts. The y-intercepts are easy. The y-intercepts, or intercept, means let x equal 0 in the original equation. So f of x would be negative 3, take out the x, put in a 0, plus 6, take out the x, put in a 0, plus 1. So f of x is equal to 1. So the y-intercept is x is 0, y is 1. Very, very simple. Okay? Let's look at E. E says, which of the following most closely resembles the graph of f of x equals negative 3x squared plus 6x plus 1? Well, I know it can't be the first two, because you said it had to open down, and those two open up. So I look at the second one, and I'm like, okay, how am I going to know? Well, we know what the vertex is. We know that the vertex is the 0.14. If you look at the last one, that vertex is negative 1,4. So I know it's not that. So it's the third one. I'm just going to write third. I'm not going to draw all those. It's the third one. And I can tell just by looking at the pieces that I found out. All right. Let's look at, now that we've analyzed a quadratic function that was in Form 2, let's look at two different ways to graph a quadratic function. So let's look at method 1. And method 1 is using transformations. And I'm just going to tell you, I prefer this, but you've got to know, whoops, it's hard to talk and write. You've got to know what you're doing with transformations and remember what each of those transformations looks like and what it does to an equation. So let's start with method 1. We have example 2. It says graph the function f of x equals 1/4 times x squared minus 2 using the parent function and transformations. Okay? So let's start out, and it says graph the parent function. Well, what's the parent function here? The parent function is f of x equals x squared. Okay, we can do that. We know that we have these points because you've memorized that, and there is our parent function. Now, what's been done to the parent function? I'm going to do this piece first. It's always easiest to do the vertical translation, the vertical shift last. That's the negative 2. So here, I am going to do, before we graph it, I'm going to do f of x equals 1/4 x squared. Now let's think about what it does when you multiply a parent function by a number in the front. If that number is greater than 1, it stretches it up and narrows it. But if it's less than 1, like a fraction, if it's between 0 and 1, remember it pushes it down, it compresses it, it widens it. So this is a vertical compression, or it widens it. Now, how do we know how it widens it? Well, let's look at some points, okay? So let's go back to the parent function, and let's do a couple points. I'm just going to call it y here. So if x was 0, y would be 0 squared, which is 0. If it's negative 1, it's 1, 1, 1. We've got negative 2. It's going to be 4. 2 is also 4, and we graphed it. All right? Okay, well, when we do this vertical compression, what is getting changed? Well, look at it. What got changed? The x squared got multiplied by 1/4. I took a fourth of what it used to be. So if I go x, y, and I start with 0, and I go back to what I had on my parent function, I had a 0. Now I'm going to have 1/4 of 0, which is still 0. So I know I have this point, okay? Let's do them in order. Let's do negative 2. If x is negative 2, it used to be 4 on the parent function. Now it's going to be 1/4 of 4, which is 1. So I have the point negative 2, 1. Now let's do positive 2. Here, positive 2, it was 4. Now it's going to be 1/4 of 4, which is also 1. So positive 2, I have 1. And now you can see how it is widening. I could continue with negative 1 and 1 if you wanted to do that. You could pick any points. Once I have those two, I can see how it widens. So that was a vertical compression. All right, let's go to the last graph. And that is, I'm going to move this down a bit. We want to do f of x equals 1/4 x squared, but we have to move it down too. So it's going to be this graph shifted down too. Well, that's easy to do. All right, so let's do our points. And now what we're going to have is we're going to have what we had in our y column here. So 0, negative 2, 2. Let's do plus or minus 4 instead of plus or minus 1. We're still going to have 1/4 of it, but now it's going to have a 2 subtracted. So instead of being 0, like it was there, it's going to be minus 2, which is negative 2. So we have the point 0, negative 2. That's the vertex moved down. When it was negative 2, instead of it being 1, it's going to be minus 2 more. So that's negative 1. So we have the point negative 2 minus 1, which means we're going to have the point 2 when it's 2, we still have a 1 minus the 2. So that's this point, 2, negative 1. If it was 4 or negative 4, let's do that here. I'm just going to change that. If it was negative 4, we took 1/4 of that. 1/4 1/4 of, not 4, pardon me. We didn't do negative 4 and 4 over here. If I do those, you'll see that this is 16. So we would have 1/4 of 16, which is 4. If I do 4, I would have, again, 1/4 of 16, which is 4. So plus or minus 4, I had 4s, and now we're going to subtract a 2. So that's going to give me 2. So at 4, I would have it be equal to 2. And you can see it's that same graph, the widened graph that we had, except now it's been shifted down to, basically. So that's doing it with transformations. Let's do one. Example 3. Using transformations, but we're going to do one first that needs to have the square be completed. So let's look at example 3. It says graph the function f of x equals x squared plus 4x plus 2 by first completing the square. Well, now you got to remember, how do we complete the square? What we do is we subtract from both sides, and we get x squared plus 4x plus some magic number equals negative 2 plus some magic number. Okay, so to complete the square, we take that middle coefficient, we divide by 2, circle it, and square it. So we're going to add a 4 to both sides, and so we know that x plus 2 squared equals 2. Okay, now I need to get everything on the same side, so I say x plus 2 squared minus 2 equals f of x. Now, I could actually, this is in form 1, but I can still use transformations. So let's write it as y equals x plus 2 squared minus 2. And look at what's been done. Well, we know on the end, that's a vertical shift down 2. Do you remember what the transformation is when it's inside with the x? That means left 2. So we start with the parent function, as always. The parent function is this. Y equals x squared. I'm not going to do the points this time. We're just going to use just the transformations. First, we're going to do the left 2. So I take that parent function, and instead of being where it was, which I'm going to do real lightly with dotted, it moves over 2, and so now it looks like this. Okay, so that was left 2, and it's y equals x plus 2 squared. All right, and then finally we're going to do this vertical shift down 2. So I'm going to take the graph that I had, I'm going to do it real lightly. That's what I had here, and now I'm going to move it down 2, and it looks like this. So that was down 2, and that gave me y equals x plus 2 squared minus 2, which is the same thing as that graph right there. All right, because you can't tell by looking at that, like you could in our last one. We could tell what had been done to it, but in this one, it's in form 2, and you can't do graph it by transformations until it's in form 1. So it must be form 1 in order to use transformations. All right, well, what if you didn't want to use transformations? Okay, what if you didn't want to use transformations? What if you wanted to do it with it in form 2? All right, let's do that. So let's look at example 4, and let's answer this one question first. It says, how is the function in example 3 different than the function in example 2? Example 2 was already in the correct form to use transformations. Example 3 wasn't, so we had to complete the square first, and that's kind of a pain. So let's go to example 4, which is f of x equals x squared plus 2x. Now, that is not in the form to use transformations. That's not x squared plus 2, it's plus 2x. And we don't want to complete the square. What we're going to do instead is we're going to analyze that graph, and we're going to determine how we can graph it from the pieces that we find out. So let's go. How does it open? Well, the a here is 1. So it opens up because the a is greater than 1. By the way, the b is 2, and the c doesn't exist, so it's 0. So it opens up. Let's find its vertex. The vertex, remember, is negative b over 2a, and then f of negative b over 2a as a point. So let's do negative b over 2a, or negative 2 over 2, negative 1. So the first part of our vertex is negative 1. And now we need f of negative 1 equals negative 1 squared plus 2 times negative 1, or 1 minus 2, which is negative 1. So our vertex is at negative 1, negative 1. We found it. So you can see there's advantages and disadvantages to the form that it's in. It's easier to do the vertex when it's in this form, because I knew that vertex was negative 2, 2. I can tell by looking at it, and right there it is, negative 2, 2. Here I can't. I have to do some work. All right, let's look at the axis of symmetry. Once you do the vertex, you have the axis of symmetry because it's always just going to be the line x equals whatever you got for that x part of the point. So x equals negative 1 is the axis of symmetry. Let's find the y-intercept first because it's easier. We're going to let x equal 0 in our original equation. So f of 0 would be 0 squared plus 2 times 0. So f of 0 is 0, and our y-intercept is the point 0, 0. X-intercept is a little bit harder because we're going to let y equal 0, which means we would have 0 equals x squared plus 2x. And how do I solve that? I factor it. 0 equals, factor out the GCF, and now use the zero factor property. Either x equals 0 or x plus 2 equals 0. This one gives me the point 0, 0, which I already knew. Or subtract a 2, x equals negative 2, and that one gives me the point negative 2, 0. So there are two x-intercepts, the point 0, 0 and the point negative 2, 0. All right, let's look at the domain. Go back to your original function. Is there a domain restriction? There's no variable under an even root, and there's no variable in the denominator, so it's all real numbers, or negative infinity to infinity. The range, remember this is a parabola, so it does have a midpoint. Where is that midpoint? Well, think about where the vertex is. Negative 1, negative 1. I think at this point in time, it's probably time to graph that. So let's graph what we have so far. Here is our vertex. It opens up. It goes through the point 0, 0, and it goes through the point negative 2, 0. So it looks like this. So the range can't go below y being negative 1. So that is negative 1, including negative 1, to infinity. Where is it increasing and decreasing? Well, it's increasing here. Okay, it's increasing when x is negative 1 all the way up to x is infinity. Remember, this is not a point, this is a range of values. And it is decreasing when x is negative infinity down to x being negative 1. So this is analyzing it a different way. And you may prefer this. I totally prefer transformations, even if I have to complete the square. I don't mind doing it. All right, let's look at another one. Just takes practice. Let's look at example 5. It says graph f of x equals x squared minus 6x plus 9 using graph analysis and not transformations. What form is that in? It's in form 2. It's not in the correct form to use transformations. Okay, so we have to use the same graph analysis. So let's do our A, B, and C. A is 1, B is negative 6, C is 9. How does it open? It opens up because, I'm going to put because A is greater than 0. All right, so it opens up. Let's now find our vertex. The vertex is the point negative B, so the opposite of B over 2A. And f of 6 over 2a, or the vertex is 6 divided by 2 is 3, and f of 3, so let's find f of 3. F of 3 is equal to 3 squared minus 6 times 3 plus 9, or 9 minus 18 plus 9, which is 0. So the vertex is the point 3, 0. So I'm going to go ahead and start putting some things on this graph. So we've got the point 1, 2, 3, 0. That's the vertex, and we know it's going to open up. We just don't know how wide it is yet. Okay? The axis of symmetry, right there's my x, is that line. X equals 3. So it goes through here. So it's symmetric to that line. Right there, x equals 3. Now we need to know the x and y intercepts in order to see how wide it is. So let's do the y-intercept first. It's easier. That means let x be 0. So that would be f of 0 equals 0 squared minus 6 times 0 plus 9, or 9. Okay, so we have the x-intercept at the point 0, 9. So 0, 2, 4, 6, 8, 9 up here. It's clear up there, and that tells me it goes through there, and it has to be symmetric, so it's going to go through. Here's a way you can figure it out. Notice from the vertex to this point, it was 1, 2, 3 over. So if I go over 1, 2, 3, and then go up 9, which is off my paper, I also know that that point's going to be there, the point 6,9. That's kind of a quick way to do that, using that axis of symmetry, okay? But we still have to find the x-intercept. We found the y-intercept. The x-intercept is when we let y be 0. So we set the equation x squared minus 6x plus 9 equal to 0. Let's see if it's factorable. Are there factors of positive 9 that add up to negative 6? Sure, negative 3 and negative 3. So x minus 3 times x minus 3 equals 0. 0 factor property, x minus 3 equals 0, or don't need to write it again. So x is 3 when y is 0, and we already know that. We already knew that was the x-intercept. It's on the x-axis. We didn't really even need to find that. It happens to be the vertex. That one was an easy one. It's increasing on what interval? Well, it starts increasing at x is 3, and it goes to x being infinity, and it's decreasing over here, coming down from x is negative infinity to the point x is 3. Okay, that was a much easier one. All right, let's kind of do the reverse. Let's go to example 6. Then I'm going to give you the information, and then you're going to have to write the function. It says determine the quadratic function whose vertex, so we know the vertex is 1, negative 5, and we know the y-intercept is negative 3, so 0, negative 3. And the graph is shown. I'm not going to sketch it. You can see it. So how do we do that? Well, if we're given the vertex, that tells me that I need to use it in the form that shows the vertex. So we want to use form 1, which is, go back in your notes and look at form 1. Form 1 is f of x equals some number times x minus h squared and then plus k. All right, well, how can we use that to get the equation? Well, I have the vertex, so I know the h and I know the k. So I can start with this. I can start with f of x equals some a, because I don't know what that is, but I do know that the h is a 1, so x minus 1 squared, plus my k, which is negative 5, so plus a negative 5, so that should have been take away 5. All right, and what's the other piece of information that's going to help us with this? What do we know? Well, we know that f of 0 is equal to negative 3. Well, what does that mean? It means that, I'm going to put and, when x is 0, y is negative 3. So negative 3 equals some a times our x, which is 0, minus 1 squared minus 5. And now I can solve for a. So negative 3 times equals a times 1 minus 5, or negative 3 equals 1a minus 5 out of 5. And we know now that a is 2. So I can now write the equation. F of x equals a that we found times x minus 1 squared minus 5. Now, that is the form 1. Let's change it to form 2. How would we do that? We would FOIL out this and then distribute the 2 and then subtract a 5. So let's do it. F of x equals 2. FOIL that out and you're going to get x squared minus 2x plus 1. If you don't believe me, FOIL it out. Okay, keep going. F of x equals 2x squared minus 4x plus 2 minus 5. We're almost there. F of x equals 2x squared minus 4x minus 3. And now we have the equation two ways, in form 1 and in form 2. And if I ask you one of these questions, I'm going to want it in form 2. So you may want to go back and kind of look at that. All right, there's a summary here. Summary for graphing a quadratic function. Method 1. If it is already in form 1, which is a f of x equals a times x minus h squared plus k. Or, if it's not, and you complete the square to get it like that, then you can graph the function in stages using transformations. That's method 1. Method 2 is you just have what you have. It's in this form 2. And you do graph analysis. You determine, does it open up or down, get the vertex, get the axis of symmetry, find the y-intercept and the x-intercept, get an additional point like I did here with 6, 9, using that axis of symmetry, and then plot the points. It's a lot of work either way, and you're going to have your preferred method. And I will probably give you one on the test in both forms, so you'll have to be able to do it both ways.